Welcome back to Python tutorial. And this module we are going to be talking about try, except, and final. So let's just name it exception finally. So what's an exception? Exception is actually a kind of a mechanism that allow you to undo an error. So you can also call it an error handler on your program. So except this thing happen through this error, except this doesn't happen through this error. Let's just go ahead and do it. To use except, you need to try what you want to catch first, then you need to add the except itself. So let's just say if look this is it. So we're just going to say print name. So obviously this could actually look weird, isn't it? And then we say except something happen. I want to say print sorry, variable name is undefined. Alright, variable name itself is not undefined. There is no actually a variable name here actually here. Name. That's weird. Name actually here. We try to print it out. So normally, Python is going to throw an error to us, but since we've tried to catch it ourselves, we've tried to try it ourselves, then put within an exception, we are going to be able to catch that error. So let's just say try py. So you can see it's a variable name is undefined, and that is because the name itself is not actually defined. And to really get things rework or out of range, or to really make more sense, we can say except, let me just put it there. I just put it, so except an exception actually happen. So we actually mean the same thing, but it's very important to always write it this way. Except an exception actually happens. Very vital important to put it this way. So if we run the code again, we have the same result. There are a lot of exceptions that we can actually have that we can deal with. I think there is even a class of exception, if I'm not wrong. Let's just do an import okay, I think there is a class of exception, or there is a module for it, I think so. So we have except an exception actually occurs, then we print variable name is undefined, like that. So like for example, now if we have a bug like this, we just say name equals to, without putting anything in front of it, then we just say print name. So you can just throw an error message to say there is something wrong with your code, like that. And if you try to run this again, guys, so it said invalid syntax, because this is a syntax right, good, like that. I'm very happy that we have this pop-up. So this is a syntax error. Same thing, we can undo it like by just saying, okay, if we have anything that is related to syntax error right here, can you see? So fire up my own message, not Python message like this. Fire up my own message saying there is something wrong with my code, or okay, I can just say there is a syntax error in your code. Okay, so let's fire this up again. I think Python is still having power over the exception itself. Even though we try to undo it, said syntax error, invalid syntax on line 3, which is actually right. Let's throw it. You can actually throw so many kind of exception that as much as you want, except there is an exception. Just print okay, there is error in your code. I think we can actually override syntax error. I think that is why it's really popping, because when you actually override syntax error, is how do you want to feel? Let's try conversion error. So let's just say Gabriel. Let's try on that kind of error. Then let's try to say age is equals to integer of name. You know this is actually wrong to convert a string into a number like that. So let's try to pull out age. We are now having syntax error right here. Let's run this. So you said there is an error in my code. Let's see the error exactly instead of just using exception. Except I'm actually used with JavaScript. Okay, I want it to really, let's just put this out. I want to see the kind of error I'm actually generating. What's this? I'm typing in the dark, you won't believe it. I'm typing in the dark, that's why I'm having an issue with this. Alright, you can see it said value error, so we can just try, since we know the type of the error we generated is a value error, we can just try to put it this way. So okay, try this again, and don't mess with Python with syntax. It's going to yell at you, except there is a value error right there. So print value error in your code. This is going to work. So you can see we have value error in your code. So it's actually help us to narrow down the fact that Python usually have a very long lines of chunks of what's called of error message, and we can just narrow it down to ourselves. I think there is a way as error. I think there is a way to pull this out. Let's see. We can just do something like error dot message. Can't we? Okay, as error. Let's see. Okay, exactly like that. So I just it's been a long while since I've actually write this, so at least I come up with something which is nice. I can still remember something. So you can say value error in your code. Let me run this again. I think I have a clearer view. Value error in your code, invalid literal for integer with base 10 Gilbert. Exactly, because we can't convert this string into an integer, into a kind of a base 10 integer like that. We can't do that because it's actually a string. So what this for is actually meant for is that this error is actually meant for is that it gives you a little more hint about the kind of error that happens, or let me see what actually happens within your code, and that is actually how we generate an exception. So whenever you actually work with your Python, let's just say something like import Gabre. Okay, let me just say import gab. You know, this code actually contains an error, and if I try to run it, it say there is no module called gap. So we can just see this is kind of a module not found error. So instead of that, we can just wrap it in a try statement. If we don't want our code to just go ahead and cut off, you can say except there is a module not found error. Can you see? Then you can just say as error, print no, okay, module not found, like that. So then let's put in an f string, in a format string. That's why I say I actually don't need to go ahead and talk more about f string, because this is actually an f string already. So error, just put a comma like that. You can see instead of generating the Python error itself, it's usually go ahead and generate our own personal error itself. So module not found, no module name gap, like that. So that's just the basics. I think even okay, there is another one which is called finally. Finally, we always run no matter what is actually happening within your code. If there is an error and if there is no error, finally you can just say your code executed. Okay, your executed your code executed like that. So if you run this, you can see your code executed is just going to pop up no matter what's actually happen. Even when we import something that exists like regular expression, a module like regular expression actually exists. You see your code executed is just always going to pop up, and that is what the finally is all about. So it's very very important to use your what's it called, to really use try except finally within your code. So when you generate an error, you look for the kind of error you generate, because you actually don't want Python to just cut off your code like that. So you don't want Python to bring the code to an end. Probably you want it to just continue to execute the code. Then you make sure you handle the exception, you handle the error itself, and then you do it. So there's still going to be a reference video back to error, because I believe there is usually a module we usually use to that contains all sorts of error like that, error handling, and it really make it easier rather than just generating the error, then looking at the kind of the error, then manipulating it. There is always a better way to do everything with computer, right? All right, see you in the next tutorial.